Respect to our teacher. Good afternoon. All right. Good afternoon, all boys for on-site. Okay. And good afternoon online. Good afternoon, Otto, Pang. All right. P and Kaimuk. Oh, are you there?
Absent, absent.
All right.
Oh.
Okay. So last meeting, we started all about trigonometric ratio. And we talked about sine, cosine, and tangent. All right. And the first that we had discussed is or was all about tangent of the theta. Now today we will continue still on trigonometric ratio, and take note it should be for a right triangle. And then now we will have to do sine of theta or sine of an angle. Okay, so we have also taken up SOHCAHTOA, right? SOHCAHTOA. Okay, so can you remember? Okay, so let us now go to sine and its concept. Online, can you now see? Okay, so let me share it again so that everyone can see. Okay, so when we talk of sine and its concept, take note it is for right triangle, right angle triangle. And we said that a sine in a right angle triangle is the ratio of the opposite side over the hypotenuse. And take note that the Greek letter which stands for the unknown angle is theta. Okay, so we have talked that one last time. And the trigonometric functions with an acute angle are defined as the ratio of the two sides in a right triangle. And for the right, okay, you take note with regards to the angle, the unknown angle theta. All right. So with regards to the known angle, unknown angle theta, we have their opposite, adjacent, and the longest side, which is hypotenuse. Now take note of that one. Everything of that we will follow when we go to solving of, what color is that? All right. Okay, let us now go to the function of sine and how it is done. Now take a look. Sine is from the root of, okay, from the keyword that we are doing. So sine is opposite over hypotenuse. Now remember that with respect to the unknown angle. All right, so if the unknown angle theta is here, so therefore the opposite is that side. All right, and of course the hypotenuse is always the longest side opposite to the 90 degrees angle. Now, if your theta is this angle, all right, if your theta is this angle, so opposite side is that one. And of course, hypotenuse is always there. Okay? And we cannot have theta in here because we know that this is always 90 degrees. Okay? All right. So the sine, all right. Again, here is an example. Sine equals opposite over hypotenuse as shown on the figure. All right, opposite over the hypotenuse. Okay. Now take note that the sine of an angle is constant when the size of the triangle is changes proportionally. Okay, how many triangles are there on your screen? How many triangles? 3, all right? So we have there triangle A, B, and C. Okay, all are having 90 degrees. All right, and we have also triangle A, D, and E. And of course, we have the biggest triangle, which is triangle A, okay, F, and G. Now, if the size of a triangle increases proportionally in the same rate. So no matter how big is our triangle, as long as the changes is proportional, then theta, all right, this angle is constant. Again, no matter how big our triangle, as long as it is proportional, theta or the unknown angle is always constant. Why? Okay, what is the reason behind? Take a look. For triangle A, B, C, sine theta is equals to side BC, which is the opposite, BC over hypotenuse AB. So therefore, sine theta equals 5/13. That is for the small triangle ABC. Now, for sine theta of the second triangle A, D, and E. All right, A, D, and E. Take note, sine theta equals the opposite, which is 10 over the hypotenuse. 13 and 13 is 26. So 10/26 equals still the same, 5/13. And for the biggest triangle, triangle AFG, we said that sine theta equals opposite over hypotenuse. So therefore, the opposite side here, opposite is 15 over the hypotenuse, 13 plus 13 plus 13. So therefore, 15/39. Reduced to lowest term, still the same, 5/13. So no matter how big our triangle is, as long as the changes is proportional, theta is the same. All right, so the sign of theta does not change. Okay, but this is different when the angle becomes bigger. All right, for example, from triangle that one and going that one. So that means that the angles, all right, okay, if the angle here grows bigger, therefore the unknown also grows bigger. All right. So again, if the triangle or the degrees goes bigger, so also the it's not egg. Okay. All right. So take note of that one. Next, if you are to find okay, find the sine of the angle below. Again, find the sine of the angle below. Now take note, we said that sine theta equals opposite over hypotenuse. Given that triangle with regards to theta, so opposite is 8 and the hypotenuse is what? Again, take a look on that one. Theta is this angle. Opposite is 8. Now, we said that sine theta equals opposite over hypotenuse. But you don't know the hypotenuse here. You are only given 8 and yes, very good. Okay, so we will now apply Pythagoras theorem to get the hypotenuse. Okay, so since our hypotenuse is unknown, we will use the Pythagoras theorem. And it is said that the square of the hypotenuse equals the sum of A and B squared. So therefore, A squared, 8 squared plus 15 squared equals 289. Simplifying, square root of 289 equals 17. Okay, so therefore, your hypotenuse there equals 17 cm. Then, to get sine theta again, so we continue. Sine theta equals opposite over hypotenuse or 8 over 17. All right, guys, get sine theta. If your hypotenuse is unknown, use Pythagoras theorem. Any of the side is unknown, since this is a right triangle, therefore, use Pythagoras theorem. Okay? Online, did you follow? Okay, we go to the next so that we can finish this one. Oh. All right, Otto, Keimu, Pang, and P, did you get?
Yes, I get it.
Okay, so let's continue. Okay. If you are given the sine of theta, and then you are to find the length of
May I go to the
given
toilet, please?
side. Okay. Again, if you are given the sine and you are to get the length. Take note here, the sine of theta or x of the right angle triangle is 0.6. Find the length of PQ. All right, so you are to find the length of PQ. Given the sine of theta x equals 0. Yes. Yes. What's that, Pawan? All right. So given the sine of theta, which is 0.6, find the length of PQ. All right. So how do you do? How to solve? Okay, so we said sine theta equals opposite over adjacent. So sine x equals PQ over PR. PQ over PR. And we know that sine x is 0.6 equals PQ over 6. So to solve that one, you can use the cross multiplication. All right, cross multiplication, and take note, this is having denominator of 1. So you have now PQ equals 0.6 times 6. So you get 3.6 cm. So therefore, this one is equals to 3. cm. Now take note, you are given here the theta and you are given one side of the hypotenuse or the hypotenuse, and then you can get the length of the opposite side using the formula sine theta equals opposite over hypotenuse. Okay? Very good. Okay, so remember that one. Next, remember. Okay, can you recall that one? Some all hippies call hippie tripping on that. Okay, so remember the code name Soka Toa. Remember the code name Soka Toa. So for sine, opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Soka Toa. Okay, that is just to refresh our memory. Okay. Now, how to find now all of that? We said that sine equals opposite over hypotenuse. So therefore, given this one as the theta, opposite is 8 over hypotenuse 10. So therefore, sine theta equals 8 over 10. Cosine is adjacent over hypotenuse. So 6 over 10 or equals to 3/5. Reduced to Lewis term. And tangent is opposite, which is 8 over adjacent 6 or 4 over 3. All right. Take note, opposite, adjacent, and the hypotenuse. Okay, so this is the hypotenuse. Always the longest side is hypotenuse. Okay. More examples. Find the values of functions of theta. Okay, given that one. So hypotenuse, again, we use Pythagoras theorem. And sine theta, opposite over hypotenuse. So 4 over 5. Okay, another example. Okay, so we can get the length. Okay, so I guess you are now ready and you understand all. So just follow. All right. Online, please open your workbook and we will answer together, and we should finish this page. 88 and no. Not 88, but 100. Sorry. Okay, so 88, 89. All right, that's correct. Okay, on side, page 88 now. Page 88, on side. Oi. Okay, write the date also. All right, one side. Bas, okay, write down the date. Page 88. Okay, number 1, letter A. Determine sine theta as ratio of the sides in the following triangles. All right. Okay, Win, what is sine theta for letter E? Sorry, A. Sine theta equals opposite over hypotenuse. So, BC over AC. Very good, okay? So, sine theta is BC over AC. That. Okay, Bas, letter B. Oh my God, you don't have, where is your workbook? Sine theta equals FE over GE. All right, that's very good. FE over GE. All right. Letter number 2. Okay, we will finish that one. Number 2A. All right, Otto, online Otto. What is sine theta in number 2, letter A? Otto? Otto, where are you? Otto, where are you? Online. All right, Kaimuk. Sine theta number 2A equals? Kaimuk?
Yes.
Okay, what is the answer for number 2A? Sine theta is opposite over hypotenuse. So, yes, Kaimuk. Letter A. Opposite is?
I don't have book.
Oh, where is your book?
I don't
2
know.
over the hypotenuse 7. All right, letter B. Ton. Oh, letter B. Sine theta equals? Letter B. 7 over 25. Okay, letter C. Kauklong. Sine theta equals? Huh? What 12? Oh, so letter C, you don't know the opposite side. So use Pythagoras theorem. So therefore, A equals the square root of 13 square minus 12 square. All right, so minus 12 square. So what is A? 13 square is 169 minus 144 equals square root of 25. All right, so therefore A is 5. So sine theta equals 5 over 13. Okay. Okay, letter D. Pawan, what is the answer? Letter D. Yes, Pawan, letter D. What is the answer? Sine theta equals? Huh? Opposite side is? Hypotenuse is 20. All right, so you use again Pythagoras theorem. So therefore, A equals? What, 20? All right, 20 square minus 12 square equals square root of 256. Or that is equals to 16. Yeah. Okay, so what is sine theta now? Pawan. 16 over 20 equals 4 over why 10? 4 over 5. Good. All right, you answer letter E. Only one number, so that we go to number 3. Okay, take note, we still have how many minutes? 8 minutes. Okay, so you answer letter E now. Yeah. Okay, so we go to number 3. We go to number 3. All right. Oh. All right, number 3. Find the value of x in each of the following triangles with a given value of sine theta. Okay, so letter A. Sine theta is, okay, look at the triangle, find the opposite. So that is 3 over 4 equals, the opposite is x over the hypotenuse 20. So you have now 4x equals 60. All right, so simplify. All right. X equals 15. Oh, you have only 5 minutes. So make it faster. Sine theta equals. Okay, so 0.6. Opposite is 12 over x. All right, so x equals 12. All right. Divided by 0.6. X equals, what's that? 20. All right, 4 minutes more. 4 minutes faster. Letter C. Sine theta is. Oh, so use Pythagoras theorem to get the opposite. Okay, so 5 over 13 equals x. X over, huh? X over 13. X equals 5. All right, that's correct. And then value of the other x, mm. Okay, so 13 square minus 5 square is square root of 144. So x there is 12. Okay, so that is square root of 13 square. How many seconds? 3 minutes. Letter D. All right, you answer letter D and letter E. That will be your task. Okay, letter D and E. All right, so you answer that one. Oh, okay, make it faster so that after the time we go home. Online, you answer letter D and letter E. You have already A, B, C. Finish? Okay, you can pass if you are finished. Online, you have 2 minutes more. Online, you have 2 minutes more. Yeah.
I can see number.
What is?
I can see.
Answer?
Yeah.
Why? I don't have answer. This one.
Oh, okay.
All right, on site and online, we have 1 minute more. You solve letter D and E only. Okay. All right, so we have less than a minute. Thank you so much, Kaimu, P, Pang, and Otto for joining the class, okay? So thank you so much and finish the task that you have, all right? You can take a photo of that one and send it to the group. So thank you so much and see you again on the next.
Thank you, teacher.
All right.